because it seems so far in the future, right? Like no one
Hmm.
is announcing plans, almost no one is announcing plans right now to try to have babies in space. But if we want permanent, self-sustaining human habitats, one of the things we have to be able to make in space is more humans. And there's a lot of questions about if that's possible. Biologists have not answered that question yet. Human medical researchers have not answered that question yet. We don't even know how to research that in an ethical way. And then if you go even further into this hypothetical, we've figured out how to grow healthy children in space. Would they be able to return to Earth?
Okay, welcome back to the Cambridge Forum, coming to you live via Zoom. I'm Curt Jaimungal, your guest moderator for today, and I host a podcast, a science podcast called Theories of Everything, where I explore physics, philosophy, consciousness, and AI with researchers from around the world. Today, we're revisiting a question that's captivated humanity since we first looked up at the night sky and wondered, what's up there? More currently, what are we up to in space? Carl Sagan once said, exploration is in our nature. We begin as wanderers, and we are wanderers still. For 75 years, NASA carried that torch, exploring the unknown for the sheer joy of discovery and benefit of humanity. However, the political landscape has shifted in recent years, and now private enterprise is competing with public science. So billionaires, for instance, are racing to Mars, and we're forced to ask, is our journey to the stars still driven by discovery, or is it driven by dollars? Are we cosmic explorers or cosmic exploiters? To help us navigate these questions today, we have two distinguished guests I'm super excited to bring to you. Well, Cambridge Forum is bringing them to you. Dr. Natalie Cabral is an explorer and astrobiologist, and also the director of the Carl Sagan Center at the SETI Institute. Cabral researches habitability and life beyond Earth and develops exploration strategies for NASA. Her recent book, The Secret Life of the Universe, was named one of Scientific American's best books of 2024. She also holds the women's world record, if I'm not mistaken, for free diving at altitude. Dr. Erika Nesvold is an astrophysics engineer who has worked at the NASA Goddard Space Center and the Carnegie Institution for Science. Nesvold is the author of Off Earth: Ethical Questions and Quandaries for Living in Outer Space. And she's also the creator of the podcast Making New Worlds. She's also the co-founder of the Just Space Alliance, a nonprofit advocating for a more inclusive and ethical future in space. Welcome to the both of you. Welcome to all of our live audience. Here's a first question to you both. I'll start with Natalie, but then Erika, I'd like you to answer. What originally drew you to astronomy?
That's an interesting question. I think that nothing in particular. It was in me. If I believe my mom, she said that's the first thing I said and pointed to, the stars, and I never stopped from there. So it was in me, seriously. I never wanted to do anything else, and it was not a straight line, but you have to be perseverant. So it's just a passion, let's put it that way.
So that's super interesting. My first word was fish, but I have ocean phobia, so I've I have the opposite experience. Erika.
It's funny. My mother also tells a story about me commenting on the night sky at an
See?
age when I only had a few words, some of which were stars. Um, I was also exposed to science fiction at a young age, which is a risk factor for becoming an astronomer. And then excelled enough in and enjoyed math and computer programming as an adult that astrophysics was an unsurprising waypoint in my journey.
See, we are very different. I sucked at math and physics
I try
earlier
to,
on. It came late to me. It came late to me, really, in my 30s. But that's maybe why I started with, natural science and earth sciences and then went to planetary sciences.
I should say, because I do try to reassure students, you don't have to be good at math or programming to be an astronomer. Uh,
Exactly.
we take different journeys to get to the same place sometimes.
Natalie, your book, The Secret Life of the Universe, has been called astonishing by the New Yorker. In it, you support the idea that life exists elsewhere in the universe. And I'm curious, what evidence do you base that belief on?
It's not a belief because science is not about belief, it's about data. And the only thing is that I don't believe there is, a lot of life out there, but there is evidence that the likelihood for life to be out there is significant. We are made of the most common stuff that exists in the universe. Carbon, oxygen, nitrogen, you name them, you know them. All these elements are the most common in the universe. That's not by accident that we're made of them. And so when you're looking now with exoplanets, we also find an incredible amount of worlds where biochemistry as we know it, which is based on water, could work. So it's not saying that there is a lot of life out there, but the likelihood for it being out there is high. And then we can go down to the rabbit hole of what is life. Uh, and then this will open to different debate because we can talk about the origins of life, which involves the biochemistry we were talking about, or we can talk about the nature of life, which is different.
Okay, so I want to go down another rabbit hole of definitions of, so this one's in consciousness.
Uh-huh.
My understanding is that you believe consciousness is not a function of the brain necessarily, but it could be a universal principle. I believe that's a quotation, universal principle. What do you mean by that?
So first you have to stop saying belief when you're talking to scientists. And
Well, I
second,
could I could use the word credence,
no,
sure.
it's just, and that's an important point. The only belief we put is in the hypothesis. We're formulating hypotheses about, we have observation and we have science question and we make hypotheses. But when it comes to consciousness, um, it is certainly, another type of debate, just that what is life, what is consciousness, what is intelligence? All of these big questions we don't really have an answer for. We are trying to find definitions. And it's not my work, and it's not only, my belief, but when you're looking at what quantum physics and astrobiologists and neuroscientists are coming up with right now, it's just me looking at converging evidence that consciousness could be, and there is a could right here, something that is not the result of our evolution, but a principle in the universe. And the real difficulty for people is to think about this in terms of, oh, but consciousness, if it's out there in the universe, so then all of a sudden we're talking about a being somewhere, No, it's a process, probably a process that's driving how energy and information flow. But we're at the very beginning of all of this. So I have no answers to that. But to me, when I'm looking at the advances of quantum physics, of neuroscience, and astrobiology together, I think that in the next few years, we are going to have some important, new research avenues. And some astrobiologists are already working on this. You would have been surprised to know that Paul Davis and the kind are looking and working with neuroscientists and others to try to figure this one out. So certainly information and energy are, at the base of all of this because this is what's the most abundant in the universe. This is what our universe is, manifestation of that. So, and you know why? And here I am going to make an exception. I'm going to start talking not as a scientist, but just say, I really like the idea, or let's say the hypothesis, just because all of a sudden, you don't have to be a complex organism to be conscious, to be, aware of some level of what's around you. And we are talking about not having consciousness or not having consciousness. We are talking about different level of consciousness depending on your complexity, on the complexity of your neural box that allows you to tap into this universal thing. And I like it too because I think that consciousness, intelligence, etc., humans have too big of an ego. We think we are different. We think that, we are intelligent and we are aware. We agree that some of the species, maybe, a few dozen are intelligent too, could be aware too. But everything else, we are so far superior to that. Whereas here, with that model, we are talking about a continuum across complexity, across evolution, and across a neural access to something that is universal. So we'll see. I don't have an answer for that. And right now, I'm just looking and reading a lot. And this is fascinating.
Would you ascribe consciousness to microbial life?
The thing is that you are asking this question and it sounds provocative. But if you are saying that consciousness is the ability to move information and energy in some ways, then, microbial life is doing that at their level. It has nothing to do with us and their perception of the environment, the perception of the planet, and their interaction with what's around them is vastly different of ours. But with humans, consciousness is so associated with culture, with beliefs, with religions or philosophical patterns, for instance, that it tends to isolate human from the rest of the biosphere, and this is where I really depart from.
Okay, so I'd like to talk about intelligent life. It's said that there's evidence for microbial life or potentially evidence for microbial life, but we haven't yet, there's no consensus that we found some intelligent life evidence or evidence of intelligent life. So what is the definition of intelligent life? And I also want to know, we constantly say life as we know it. So what the heck would life as we don't know it be? That's also an odd
You
question,
have
I
a
know.
knack for very simple question with very simple answers, right? So let's go back to microbial life. We just talk about consciousness and microbial life, and I just mentioned to you that we don't have strict definitions for consciousness, for intelligence, or for life. So that's a starting point. We have working definitions, to address some part of that. But in the same way that consciousness, it would seem reasonable to me to think that consciousness is a continuum, for our awareness, let's say, is a continuum. Intelligence has to be the same way. It has to be a continuum. We don't have an a definition for intelligence. We have one for humans, being capable of archiving of a record and maybe not even technology, because we know species that are, building tools and doing things. But there is a definition or several for intelligence for humans. But for me, a bacteria like a cyanobacteria, the one that formed the first stromatolite 4.5 billion years ago, that still exists today, after facing so many environmental changes and changes in, well, adaptability, let's put it that way. I am working in the Andes, and I can tell you this is exactly the same organism today as it was 3.5 billion years ago, embedded in that tiny thing that is, a few tens of microns wide. You have the tool that have been developed for 4 billion years or close to, and they are switching on and off the genes that they need for the time they are at, in the environment they are in. And so there is some form of intelligence right there. What do we call intelligence? We define once again intelligence as us human being, but intelligence, just like consciousness, is probably part of a continuum. And intelligence for a bacteria has nothing to do with intelligence with a human being or with a dolphin or with anything else, which is absolutely fascinating to me when I think about, you were saying, advanced extraterrestrial intelligences. And there is one key word when you are thinking about that. You have to think about coevolution. We are not looking for life out there. First, we don't know what life is. We just said that. We are looking for the evidence of a coevolution of life and environment. Life didn't appear on Earth, it emerged from our planet. There is something special about life that we still have to understand, but it emerged from our planet. And then, as much as our planet provided the physical and chemical boundaries for the type of biology that can develop in it, once life was out there, it modified the environment too. So for 4.5 billion years now, it's been this kind of dance of life modifying the environment and environment modifying life, and having all life in it adapting to specific niches. And so the intelligence is probably, how fast you can adapt, and you can take advantage of your environment and survive. So going to extraterrestrial intelligence, what I like about it is that, of course, they are going to be, emerging for a very different coevolution than ours. So what does that say?
Now, Natalie, I have so many questions. I'm just going to ask you one more prior to moving on to Erica, and then I'm going to have you both converse with each other, and then get to audience questions. So, audience, as you're watching, if you have any questions, please note them down or even write them in the chat. Natalie, what I want to know is, we talked about microbial life. There could be microbial life underground in Mars. So let's talk about Mars for a bit. Human colonies on Mars. You've noted that there are harsh conditions there, so it takes many months to get there. There's radiation, rocks flying down, and you have to live underground. It doesn't sound too inviting. Now, look, I'm a recluse, so that sounds like the ideal place for me, living underground, away from people. But you suggest that the moon might be a better place to start.
Oh,
Why
well,
is that?
in terms of learning how to become an interplanetary species, I mean, certainly the moon is much closer to home, just practical reason and logistical reasons. Believe me, I am leading expedition in impossible places. So I think that logistics and plan B is always a good idea. So before we ship people 6 months away with the fastest spacecraft that we have right now, living in conditions that are way worse than what we have in Antarctica. And guess why we don't have a town or a village right now? In Antarctica, we only have research station is because it's really tough. And it's nothing compared to Mars. So there is a reason to that. There is a reason to that. So the moon might not be as fun, although we can debate that. I think that there are lots of things that we can, learn from the moon scientifically. But from the standpoint of becoming interplanetary, you might want to learn the ropes, close to home. That would be my point. And as an astrobiologist, and that might go back to Erika's ethical, reason. We have been exploring Mars for close to 50 years now. Next year, Viking will be 50 years next year. And Viking was the first biological experiment on Mars. It was also the last. And there was a good reason for that, because we didn't have an unambiguous response to the experiments that were on Viking, because we didn't know the environment. We really didn't know the environment of Mars, and we couldn't tell whether what we were saying in the data was because life was present or something else. And the debate is still going on today. But because of that, we have been doing incremental, missions, trying to learn the environment, trying to learn the geology, and blah, blah, blah. And only with Perseverance, the rover that's right now on Mars with Curiosity, but Perseverance has been labeled the first, search for life. In fact, it's, in my views, a Curiosity on steroid, not really a life-seeking mission yet. But in truth, we haven't been searching for life on Mars yet in a true fashion as biologists would do. And so if you were going to send humans now, even if I think we're not ready for it, then you have to worry about humans being there, knowing today that we are microbiome, we are walking microbiome, and we are carrying with us bacteria and microbes that probably wouldn't find Mars too extreme to, to just make it their home. So there is that. And there is the ethics of can we just step in onto another planet without knowing if something is alive there? That's another ethical question for Erika right there. There has been debates forever. Do we fence Mars if we are finding microbes? I'm pretty sure how this one is going to end, but there are lots of debates as well there. But the truth is that there are still many questions, and the question of life, although we have some interesting, markers with curiosity and perseverance, is still out there. So this is another good reason to stay close to home and let science do its job for a little while longer. Then when do we pull the plug on searching for life on Mars? It's another question, but I will stop here.
Erica, let's move on to you. Speaking of being off Earth, you have a book called Off Earth. You ask a question, which is what kind of world do we want our descendants in space to inhabit? Please explain to me and to the audience why that question is important to you.
Well, I think most of us who are trying to make our lives mean something, one of the things we think about a lot is what we're doing for the future, whether that's our personal descendants or just the future humans who might live in the world that we are co-creating at the moment. And I argue that that thought process should include any humans that we expect to live in space someday, especially as we're actively making plans, as some people are, to create these communities out in space, maybe sustainable, permanent human settlements, or even just outposts in the near future. And I argue that the harsh environmental conditions of living in space will make the human communities there more vulnerable to all kinds of issues, not just vulnerable to the harsh conditions of space, which are very deadly, but also vulnerable in terms of making people vulnerable to exploitation or oppression or breakdowns of the sort of societal things that we put in place to make healthy, thriving communities. Natalie's an explorer. She's been to amazingly extreme places here on Earth, it sounds like, and all of those places are beach resorts compared to what trying to live on Mars or the moon will be like. And I think people who get excited about the idea of humans living in space, it's very easy, especially watching science fiction, to forget how thin the barrier between life and death will be.
I see. Now there's a lifeboat argument that I'm sure you're aware of that, hey, we should and in fact need to become multiplanetary as a species because well, we don't want to put all our eggs in one basket. If something happens there, then there's extinction for all of us. That sounds logical. It sounds, well, I understand you're skeptical about it. So why?
It's actually the argument that I find most convincing of all the arguments that you hear floating around about why we should create human space settlements. I also believe that we should try to prevent the extinction of the human race. There's philosophers who debate about that, but I'm all for preventing the extinction of the human species. And I do believe that the eggs in one basket argument that you hear a lot, which is that we know that things can happen to this planet that can make species go extinct. It happens a lot, and diversifying into different planets might prevent some of those existential risks. The problem that I encounter and that I point out with that argument is that once you're making an argument like that with the stakes as high as they possibly can be, we're talking about the survival of the human race. It makes it hard to have any constructive conversation where you're bringing up criticisms of specific plans. If you say, well, maybe your proposal for a space settlement on Mars would lead to a lot of labor exploitation or oppression or environmental resource overuse, it's very easy for the other person to come back and say, oh, well, do you want all humans to die? And so I think it can be damaging to these productive conversations to skip straight to the existential risk argument. I find it motivating myself, but we have to get into the subtler, more nuanced questions of, okay, we want humans to survive at what cost? What do we want those surviving communities to be like?
Okay, so you're not against being interplanetary. You're against You ask the question, okay, well, what are the current routes to get there? What are the plans on the table, and what are the pros and cons of them?
Absolutely. I am in favor of human space settlement. I have a lot of colleagues who are against it. I think it's very useful to have conversations with people who argue against space settlement because they're our best critics. They can point out all the flaws in our plans very well. But I'm for it in some form. But my argument is just that we should be really deliberative about what kinds of communities we want to build in space and spend the time and effort to look at the past of human societies here on Earth, look at the present, consult with people who normally aren't in the space business, but who have a lot of wisdom and knowledge to offer us about lessons learned here on Earth that we can use in space, so we're not just repeating the same mistakes that we have made here on Earth.
Why do you think so many billionaires are interested in Mars?
It's certainly the fad right now, isn't it? I think Mars is more appealing than the moon for a number of reasons to that type of person. One is that humans have been to the moon, and so anyone who's really motivated by the idea of a frontier sees Mars as a frontier that humans haven't yet reached. It's bigger. It has some resources that the moon doesn't have. I could go into the chemical compounds that are useful there, but also it has an atmosphere, and so there are arguments to be made that you can build a more self-sustaining sort of settlement there. Um, I think there's also just a cultural element that it's what people are talking about right now.
There's also a question of suppose you were to grow up on Mars, then because it's a low gravity environment, you wouldn't be able to then survive on Earth. So tell me about the ethics of that.
So I have a whole chapter on reproductive ethics in my book, which is funny because I talked to bioethicists who had never thought about space before, and they were thrown by this. But because it seems so far in the future, right? Like no one
Hmm.
is announcing plans, almost no one is announcing plans right now to try to have babies in space. But if we want permanent, self-sustaining human habitats, one of the things we have to be able to make in space is more humans. And there's a lot of questions about if that's possible. Biologists have not answered that question yet. Human medical researchers have not answered that question yet. We don't even know how to research that in an ethical way. And then if you go even further into this hypothetical, we've figured out how to grow healthy children in space. Would they be able to return to Earth? We have no idea. No one's tried this, but there is speculation based on what the space environment does to adult bodies that makes people speculate that perhaps growing up in a low gravity environment would mean, for example, your bones and your muscles don't develop the same way, and maybe Earth gravity would be impossible to survive. You see this in science fiction a lot. It was a main plot point in The Expanse. Um, and so one of the questions I ask in my book is, what are the ethics of that situation? Is there something that we would be doing by intentionally creating children in space and raising them in space? If we did that and it prevented them from ever being able to go back to the planet that their ancestors evolved on, would we be taking something from them? And it's a complicated question. This is a sort of question that parents who end up being refugees here on Earth have to figure out is, what is they have to make that choice for their children about whether to take them to a new place with the idea that maybe they might not ever be able to return home. And so, like many of the questions I ask in my book, this is a question that is already asked on Earth by humans in some form.
Okay, let me pose a question to both of you. We've already damaged the Earth. Some even say we've passed the tipping point, so it's irreparable. And before we go to a new planet, some people say we need to demonstrate that we have good stewardship here on Earth before we're allowed to go overseas somewhere else. And I want to know why you think does that argument land for you? Why or why not? And we can start with Natalie, please.
Yeah, so this is something I discussed a lot. Um, Looking outward doesn't mean that we're not looking inward. And it's especially true when you're looking for and searching for life on beyond Earth, and you're exploring beyond Earth, is when you are asking, are we alone? We are the only species, we're the only data point. So every single question that we put out there are in fact questions about ourselves. We don't have any other model. So basically, space exploration is a gigantic mirror into ourselves, into knowing ourselves better, knowing our environment better, because we have example in front of our eyes in the solar system of what a runaway greenhouse atmosphere does. That's Venus. What happened when you're losing the water, and that's Mars, for instance. All the lessons are in front of us. And what is the beauty of space exploration is that we want to understand how that happens. So we are building planetary missions that need to have smaller instrumentation, more performing instrumentation. And we take those instruments and we take that technology to look back at the Earth and monitor our own planet. So it's not one or the other. We can do both, and we do both. And this is something, in fact, that the public, interestingly enough, don't know enough of it. They are bathed in their everyday life by technology from space explorations, from, the high-tech stuff like LASIK, the LASIK surgery. Well, 40,000 laser measurements a second to dock two spacecraft, for God's sake. Your shoes, the air shoes, the tennis shoes, thanks, your mattress, baby formula, and other things. It's everywhere. And also small stations that are going to tell you with artificial intelligence so much faster, understand the patterns better of our changing planet. This also comes in a good deal from planetary exploration, all of this monitoring system. So it's not one or another, both just feed each other. We are learning what could be habitable environment beyond the Earth by exploring extreme environment on Earth. We get to those extreme environment on other planets, and we are, finding out maybe some of the aspects of our question that were right and other things that might not have been so right. So we learn how to reformulate better question. And we learn a lot in terms of evolution of planetary atmosphere, of, planetary geology. And all of this is being used to understand better our planet and our place on our planet. And we're talking about coevolution. And also learning that every single act, every single gesture that we do, everything we take, everything we put out there in the system is going to come back to us in one way or another. And we are so active as a human species that thermodynamics being what it is, it comes back to us as a form of heat, right? But it is time for us to learn that we are one with our environment, and we are learning basically how the system works by looking at the evolution of other planets out there. And real quick, because I want Erika to chime in this too. You were talking, about diversifying our environments, and that goes with some people say, oh, we should live because the Earth is doomed. First, the Earth is not doomed at all. The Earth will survive. The environment that's favorable to us is is disappearing fast. That's a different question. But what you talked about, Erika, this is called dispersion in ecology. And it has been existing for as long as life has existed. Dispersion is a way of survival. It's evolutionary, it's beneficial. A species that can adapt to many different places has a larger chance to survive, obviously. And it's also an instinct when something is going to change. There is something in and when I say in the cell, even bacteria, that somewhere senses and then starts to disperse. You see ecosystem do that. And I actually wondered if all of a sudden, all these billionaires wanting to live for Mars or somewhere else are sensing something, instinct telling them that maybe, Earth is in a bad way. So this is
interesting because many people critique people who are damaging the Earth as you're being selfish, but it sounds like what you're saying is actually, no, you should be selfish. Just recognize that the self encompasses even the Earth, and so we need to be protective of a wider
we're not
gamut than just your
selfish.
individual
I mean, we are selfish as a species. Humans are highly selfish as a species. They don't care about the biosphere. It's instant gratification right here, right now for the whole survival of the Earth. But that also puts us in a position to say, oh my God, we can live, outside the biosphere, which is not true. And this is what we are realizing right now. I was just
Okay,
making a
I'd like to
comment
get to Erika.
as
Oh,
an ecological principle that dispersion is what species do. All of the species, not only the humans, microbes do that. All ecosystems do that. And to go back
so
to your, migration to Mars, etc., it's not the migration of humanity to Mars. It's going to be a select number of people. So who's going? Who's not going? How do you choose? And I'll pass it on to Erika.
Yes, I agree with Natalie that it's a false dichotomy. There's so much we can learn about all sorts of different topics by going to space that then can be used back here on Earth. So much of our space-based technology is used by people here on Earth, is used to study the Earth and the very climate change that we're talking about. But I think what people try to push back against is this idea of what some people call a disposable planet mentality, that we've used up this planet, we should just move on to the next one, which first of all would be a pretty bad attitude to have, because then you never learn how to live sustainably with your environment, but also is just not the case. The worst climate change scenario predicted for Earth would still leave this planet more habitable than Mars is. And as Natalie pointed out, some bulk of humanity will be staying back here on Earth no matter what. And going to space doesn't absolve you of a responsibility to those people. And so I think it's important that whatever we do, we think of ourselves as one human species, and we are trying to improve the future lives of our descendants, no matter where they end up living. And so I think that the idea of expanding and spreading into space appeals to me more than the idea of leaving, of the lifeboat mentality that you brought up earlier and that I write about in my book. And that at all times, no matter what we're learning, we need to think about how we are distributing that knowledge, these resources, in a way that's equitable to all humans, whether they came along into space or not.
So the knowledge I imagine is can be that we distribute could be positive, it could be negative. So some could be colonization. And I know, Erica, that you've in your book drawn parallels between space colonization and historical colonization. Can you tell us what risks what are we at risk of repeating?
I'm certainly not the first person to draw parallels between the historical colonization and space colonization. People who advocate for space colonization draw those parallels. Often they are trying to use the metaphors from the cultures that are dominant to advertise and to get investment in their ideas for space by saying colonization, this specific colonization that they're talking about it was such a good thing on Earth, so we should do it again in space. But that often reflects a poor understanding of the historical things that they're referencing. People talk about space will be like a gold rush. It'll be like the Transcontinental Railroad. It'll be like the colonization of North America. All of those had very bad and harmful consequences for certain groups of people, specifically labor, and for the environment. We're still all over the world struggling with the harmful effects of colonization, and the history of colonization on Earth. Some people argue that we shouldn't have any problem with using the colonization metaphor in space because there are no indigenous people to harm. Certainly, indigenous people were one of the primary victims and are today in colonized nations and formerly colonized nations. And so if there's no indigenous people in space, why do we care? But there were so many other harmful effects of that colonization mindset, that this land and these resources are just there for us to gobble up and move on to the next one, that leads to labor exploitation, that leads to resource overuse. And we've learned those lessons already, ideally. And so we should be looking at those historical lessons as we go into space.
This word exploitation has been used a variety of times across this conversation. Do you mind briefly defining it? Because some people may say, well, I'm exploiting water when I drink it. I'm exploiting my chair when I sit it. So there's a neutral-ish definition of exploitation. What are you using it? How are you using the word exploitation?
I don't think I'm aware of a neutral way to use the neutral connotation for exploitation. Usually it's meant to refer to the use of a resource, whether that's a physical resource like water, but specifically let's talk about water on the moon or Mars, or exploitation of a group of people that you want to extract some value from. And generally, it's used to mean extracting value without giving anything back, extracting value in a way that consumes that value that harms either the environment or the group of people that you're extracting it from.
Natalie, I want to know, should we be keeping this urge to explore space pure? It should just be for the sheer joy was a phrase that I used in the beginning for what we're doing, what we used to be doing when we looked up at the stars. We wanted to get there for just to explore. And there's something that's seemingly pure about that. And now it seems like there's impure intentions as well, because as soon as money is involved, people seem to not like that for a variety of reasons. And so should these not be mingled, or is there a
You
symbiotic
know,
relationship between them? Is help me
it's
understand
just
this.
like everything, many, many shades of gray. And so there is the what you call pure. I don't like this notion of pureness, and we have to move away from those things. There is us sitting on a rock and watching at the night sky and pondering about, first thing you say, it's, gosh, it's beautiful. And second, if you're a little curious, say, well, is there anybody looking back at me? Are we alone? And then you are starting to philosophize, which we have been doing for pretty much as long as we have been, watching the sky, as you were saying earlier on. So that's the passive way of doing things, not passive because we're still thinking about it, but because it doesn't involve interaction with technology, right? But as evolution goes, then humans have been better and better at building tools, and now we are interacting with the environment, and we are using these tools to answer questions about, what is out there, what are those other planets, what are they telling us about the universe, about ourselves, etc. That's the scientific way. And you can still do that on your own, not being a scientific, and just ask your question. But scientific will build a technology to go get the data and try to figure out things out of that. That's a different thing. And now you have other people who say, well, we have enough technology and enough money that there are resources out there. We are not seeing only the space as a source to address intellectual questions, but maybe economical questions. So there are all sorts of arguments that are being made out there. So we are running out of whatever, compounds or components or element. So there is a lot of that on the moon. Let's go and mine the moon. Soon we'll be running out of, I don't know what, on Earth. Let's go to Mars and find it, as if it were something easy to do. But you're right. There is now another way of accessing space. And I would say, as a scientist, I am annoyed by many, if not most, of the argumentation that those people are developing to go and access space. But there are others that make total sense to me. As a scientist, I like the idea of having the possibility to have more options, more opportunities to put a payload and go somewhere and not have to wait for NASA to have a program. And I work with NASA. I've been working for 20 years, 25 years now with NASA. I'm very happy with that. But it's true that NASA or ESA or JAXA, they have programs. And you fit into those exploration program or you don't. And you can be an extremely talented scientist, have bright ideas, but not fit into the vision, the strategic vision of exploration of those space agencies. So then you don't have the possibility of deploying your experiments or doing your own thing. And commercial space, which means that the possibility to have your science being put on commercial rockets offer more opportunities for science to be made outside of strategic visions of government. So that's a good thing. That's a good thing. The fact that it lowers the cost as well is a good thing. The fact that it probably is um, actually generating some competition. I like that because you have more ideas coming. We're making progress faster. So there are pros and there are cons. And the only thing that to me, I think we can find a meshing of ideas, of goals. And this is what's happening. There is a lot of that happening right now. A lot of private companies are teaming with scientists to do real good science. That's real. The only thing that bothers me a lot, and I'm really hoping that Erika can chime in on that, and it didn't start with commercial space. It already existed before, is that right now space is the wild, wild west. There are no treaties, there are no ethics, there
Hmm.
is basically planetary protection thing. I don't think that the best demonstration of what you can do in commercial space was to send a Tesla in space. When you know that we are burning our best spacecraft in Jupiter's atmosphere or Saturn's atmosphere to make sure we are not going to contaminate worlds that are around, you know? So I think that there will be, and there is already teaming of ideas for the best of science and the best of what commercial space has to offer. But it is very important that we start thinking about the ethics and the law, the legal aspect of being in space, some regulation, because right now you have the money, you go. This is basically what it is about. And from the scientific standpoint, this is very damageable.
I'd love to hear Erica if you'd like to respond to any of what Natalie just said
I would
or
like to
riff
say
off
that
of it.
I will push back against the idea that there are no treaties about behavior in space. There are some. There's the Outer Space Treaty of 1967,
Yeah,
which
67.
yeah, which was if you look into the history of it, to me, fairly miraculous that it got passed. It says things like you can't put nuclear weapons in space. I'm very grateful for the existence of this treaty, but it didn't anticipate the commercial
Yeah.
space industry that we see today, and it doesn't specify a lot of the questions that people have now. And as space lawyers have explained to me, a lot of what's in the treaty has just not been tested yet, and we will see that happen. And there are people who are trying to look at that treaty and trying to put more regulation into place. But the other thing space lawyers and policymakers tell me is that it's really hard for regulation to keep up with the fast pace that the industry is moving today, as Natalie just mentioned, because by definition, regulation is deliberative, and that can mean slow. And so they're trying to keep up and mitigate issues we're having with things like overcrowding in Earth orbit and things like that.
Before we get to audience questions, which if you're in the audience right now, please write them down, send them in the chat. I have a question to both of you from the forum. The forum wants to know, many people have looked at space, but many people haven't thought about the importance of going to space and what that means. So for those who haven't thought much about it, why should they care? What's at stake for the average person listening who just hasn't put much thought into space and going into it and all of what that entails? What's at stake for them? What's at stake for their children and their grandchildren? Erica, please.
Oh, I was going to let Natalie go first. I wanted to hear her thoughts on this.
Up to you, Erica. But I think
Eric,
Go ahead.
we already touched on that a little earlier, which is that uh, many people don't actually know how much space is already involved every single day in their lives. They don't leave home or come back at night without having been, interacting with space. And it's a lot. I mean, it's in the stuff that you have at home. I was joking, it's not a joke. Your mattress is probably has some kind of space technology in it. The thing you're sleeping on, right? And then you are getting dressed and you are having these nice clothes and these great shoes and well, you have space technology in that too. I'm not even talking about your car, of course. Autonomous navigation. Yeah, well, we started doing this when we started thinking about rovers on Mars, and even a little earlier than that. But that autonomy comes also from space and has been modified and bettered with space exploration. You go to the eye doctor, you're getting this magic technology that gives you your sight back, thanks also to space technology. And you are having this little med station now outside. Of course, you don't need to go to space. There were some before, but now we have miniaturization of through space technology and planetary exploration technology to help you monitor the environment around you, and so on and so forth. Your GPS, on satellites, your weather, that you are looking at every single day to know where you're going to go on weekends or if you're leaving or not because there is a storm coming. People interact with space every single day of their life. So this is what, for them in it is that every single day their life is getting a little simpler or a lot more complex, depending if you are technologically oriented or not. But let's say that we're all bathing in space exploration at all levels. And for their children, what I hope is that the technology that we use to address those questions outward about is there anybody out there? What's habitability? What's the threshold of habitability? What is coevolution? All of these questions that we are trying to address now will help us better understand and address the problems that we are having right now because we are in imbalance with our environment. Basically, what I'm hoping for the great children will be that we come to an understanding of what it means to live in harmony with our environment.
And I'll answer this question from the other direction, which is that even if you don't care about space and use your GPS without even thinking about space, the thought exercise, the thought experiment of thinking about how you would want to build a community in space lets you think about how you want our societies to exist today. And so I often point out that sort of psychological flexibility you get when you think about a space settlement. You can imagine much more radical solutions for how we would want our children's lives to look than we would have today. And so that's why I encourage people to go through this exercise and to think about these things, because talking about the future of humanity in space is talking about what we want humanity's future to look like. And I think this is something we're all invested in.
And Curt, one more thing you were mentioning my book earlier on, and I think somewhere, or maybe that's a different one, but somewhere I say from space we are all blue. And what, space exploration brings us the perspective that humanity needs right now to reposition itself with respect to its planet. And when you are in orbit, as Sagan was saying, clouds don't care about frontiers and boundaries, and you see one planet, one biosphere, one set of resources for everybody. And I think this is what space is bringing to this generation, and hopefully a message that can be carried to a future generation, which is that we have to start learning to be a planetary species before, not necessarily before, but because I think that planetary exploration is going to teach us as well to look back at our planet, but we need to become a planetary species.
Okay, so let's get to some audience questions. There's actually quite a few, and so forgive me if I'm unable to get to yours. The militarization of space has been centered in the funding of space exploration. U.S. Space Command's goal of full spectrum dominance brings the possibility of weapons in space. First, what are the ethics of using space to dominate in war? Number two, kinetic strikes in space will contribute to space junk, making future exploration difficult. Your thoughts, please. I don't have the name of whoever asked this question, but thank you for the question. Erika, this sounds like it's right in your ballpark.
Yes, I talk about war in space in my book in one chapter, but I highly recommend a book called Original Sin, which is a whole book full of this topic and walks. It's by a historian named Bleden Bowen, whose name I'm probably mispronouncing, but it points out that as this question asker points out that militarization of space has been present in the history of human space exploration from the beginning and throughout every step, every decade of the way. And while we have things like the Outer Space Treaty, which says you can't put weapons of mass destruction like nuclear weapons in space, that doesn't stop space technology from having been crucial to warfighting efforts from the first satellite onwards, and that continues today, even without imagining hypothetical technologies like kinetic impactors. And so this is something that should be present in conversations about space, and is present among space scientists who often have to confront the fact that that the technology we're developing and using for learning about space can be dual use. It can be used for militarization in space as well.
Natalie, last question. You mentioned that you're on the eve, or that we as a species are on the eve of something incredible. It's almost a precise quote. Please expand.
Oh, it goes back to our very first question on consciousness. And it's not necessarily about consciousness, but today you're starting to see a convergence of works in physics, quantum physics in particular, in neuroscience, that are, when you see articles telling you that your brain is behaving like a, quantum computer in some number of dimensions. A more recent one that says, well, maybe your brain has some direct interaction with the universe through some quantum physics as well, too. That goes, beyond my pay grade. I am seeing, as a person who connects dots, some convergence here. And I just cannot wait for quantum physics to advance a little more to see where this goes. Because if these are potentially new research avenues, in the same vein, for instance, we're talking about the origins and nature of life. Origins of life talks about environment and biochemistry, etc. Nature of life is taking life down to processes, thermodynamics and entropies and biophysics. And biophysics goes back to quantum physics. And what I like about that is that it takes life not as a thing like we are used to see it, but as an assemblage of particles that are behaving in some ways that is different than what we call inert, but without seeing the separation between both. And this is what I like, because when you are looking at what is living and non-living, we tend to create boxes as scientists to understand processes. But sometimes we get so bogged down on our, little boxes that we forget to step back and look at the bigger picture. It's not that there is life and there is no life. There is a continuum somewhere. And I think that quantum physics and the level at which quantum physics is talking about particles is going to help us bridge, this living, non-living thing. And to me, that's the biggest revolution I see in the coming years.
Okay, so I don't want to get the Cambridge Forum mad with me or upset with me, but I have a quick question for Erika that I think is going to be inspirational to many people in the audience, because they're interested in astronomy, but they're intimidated by the math. And when we were speaking off air just prior to this, you mentioned, I wish more people would know that you don't need to be that great at math, at least not initially, to dip your toes into astronomy. Both of you were actually echoing the same sentiments. So, Erika, can you please talk to the audience member who is interested in astronomy, but they just can't do the math? They don't think that they're good at math.
I did. I think we caught that on the record at the beginning of the call, and Natalie might even be a better person to answer this, because I do have some math skills that carried me right along. But one thing I've learned through my work as an astrophysicist, but even more through my work on this area of space ethics, is that people come to space, to working on or in or about space, from so many different directions, and that includes being an astronomer, but also the myriad different ways that you can work in some field related to space these days. And that includes whether you're an astronomer who hates coding and struggles with math. I've known a number of brilliant astronomers like that, but it also includes people who are engineers or lawyers or artists or teachers who want to contribute to humanity's efforts in space, but don't feel that they have the skill or just aren't interested in spending their careers doing that kind of work. There's so many other ways that you can contribute in that way. So I highly encourage you not to get intimidated by the math.
Okay, that's great. And yes, you did talk about that earlier on. We had so much we spoke about off air. I got jumbled up, but at least the people who just joined a bit late got to hear that. I'd like to thank Dr. Natalie Cabral and Dr. Erika Nesvold for sharing both of your expertise. Thank you so much.